Here's a rational function. I've got to find what the function is given these features. It's a rational function. So it's either something with x divided by something with x, or a constant divided by some function of x. It's got a vertical asymptote at 3, which is really x equal 3. So I'm going to draw the function down here. F of x equals, it's rational, so there's a fraction sign. So at x equal 3, I subtract 3 from both sides. That's x minus 3 equals 0. So for vertical asymptotes, for wholes, and the whole would have to be on the top and the bottom, the factor. For zeros, x equals a, then the actual factor is x minus a. Subtract a from both sides. So x equals 3, the factor is x minus 3. If it was x equals minus 3, the factor would be x minus minus 3, which would be x plus 3. So the sign flips and the number goes with x. So this is x minus 3, and that's the vertical asymptote down in the denominator. Here is a, the 0 is at 4. That's x equal 4. So the factor is x minus 4. And zeros go on top. And then here's a whole at y equal, not y equals 1. The whole is at x equal minus 1. So that means x plus 1, the factor that goes with x equals minus 1, has to go on top and bottom because that's a whole. It would be an asymptote if the discontinuity didn't cancel. But since it cancels, it turns into a whole. And what else? I've got the vertical asymptote. I've got the 0. I've got the whole. Horizontal asymptote at y equals 1. Well, look at the original function. X times x would be x squared. I'm just looking at the highest power of x. X times x would be x squared. And what is the number in front of that? What's the coefficient? Well, for both it's 1. So when the powers are equal, divide the coefficient on top by the coefficient on the bottom. 1 divided by 1 equals 1. Verified. Horizontal asymptote at y equals 1. So here's the function. I'm going to draw the horizontal asymptote at y equals 1. The vertical asymptote at x equals 3. Just approximately. And then I've got my 0 at 4. That'll kind of remind you what the shape of this has to be. But when you have, once the whole is canceled, when you have a linear function divided by another linear function, it looks like an inverted simple rational function. It's going to look like that. This should be approaching but never touching the axes. So it's going to be that, but it's shifted. So this kind of reminds me that it's like that, so I have to draw it like this. And then on the top left, I can use that. I can use the y-intercept. So when x is 0, what is the y-intercept? I can find that out from the simplified or the original function. I'll use a simplified. 0 minus 4, minus 4. 0 minus 3, minus 3. When x is 0, y is 4/3, or 1 1/3. So 1, there would be 2, there would be a third, and something like this. You could graph a few more points if you want, but it's just important. Now, the other thing you can't forget is to put that whole in. And the whole is at x is negative 1, which is somewhere around there. And so draw the whole in. There's a little hole at x equals negative 1. And that's it. And I'm going to show it on Symbolab. Desmos doesn't show holes, that's why I'm not showing it on Desmos, but there it is. So again, you can memorize that. Know the parent function. When you have a linear function divided by another linear function, then it just looks like an inverted simple rational function. And then you can put in the points. Or the points kind of tell you about where you have to go. I don't know if this thing's, I don't remember if it asks for, but if it asks for domain, the domain is everything except for the whole in the vertical asymptote. Well, the whole is at x equal minus 1, so it's got to be negative infinity to minus 1 in union with minus 1 to infinity, minus 1 to 3 rather, because 3 is also not included, union 3 to infinity. So just as I move to the right on the number line, I have to make sure I include all those. So negative infinity to negative 1 in union with negative 1 to 3, in union with 3 to infinity. And they're all curved brackets because negative 1 and 3 are not included. They're excluded. 3 is an asymptote. Negative 1 is the whole, the removable discontinuity. So this is the function. F of x equals x minus 4 times x plus 1, divided by x minus 3 times x plus 1. And I verified all the features on that. And I've even verified it by checking out the graph on Symbolab. Remember, you can do it on Desmos, but Desmos doesn't show the holes. I think the TI-84 calculators do show holes. So that's it for this one.